To get regular videos like this, like, share, and subscribe to our channel. Stay connected with us.
We operate the world's most advanced facility for reclaiming high-grade aerospace materials through precision engineering.
The process begins here, where retired giants are brought from storage for total material reclamation. Engines are the most valuable components, requiring surgical precision during removal for component harvesting. Every seat, carpet, and panel is removed, ensuring only the pure metallic structure remains for the next phase.
The intense heat reduces the thick aluminum skin to molten silver, as the wing section is precisely separated for recycling.
Heavy-duty hydraulic shears exert thousands of tons of pressure to reduce the fuselage into uniform segments. Advanced sensors identify the exact chemical composition of every fragment, separating aerospace-grade aluminum from titanium. The dark gray titanium landing gear bolt is significantly heavier than the surrounding aluminum.
Primary shredding reduces structural sections into uniform flakes, preparing the metal for high-purity separation.
Powerful magnetic systems and eddy currents automatically strip away steel and non-metallic contaminants. Every piece of scrap is chemically cleaned to remove paint and coatings, ensuring 99.9% purity for smelting. The basket is lifted from the tank and blasted with high-pressure deionized water jets, rinsing away the chemicals. To maximize furnace efficiency, the processed flakes are compacted into dense bales weighing 2 tons each. The final transformation begins as the bales are charged into high-temperature furnaces for melting. How millions of aircraft parts are recycled inside massive factory. how millions of aircraft parts are recycled inside massive factory. At 1,200 degrees, the structural history of the aircraft is erased, returning the alloy to a pure liquid state.
Inside the reverberatory furnace, the aluminum bales are completely liquefied, creating this shimmering pool of white-hot metal.
To ensure structural integrity, any surface impurities are mechanically skimmed, leaving only the high-grade liquid core. The mechanical skimmer arm pushes the layer of gray oxidation, or dross, into the collection pit. To regain its strength, the recycled aluminum is precisely realloyed with specific trace elements.
The computer controls the precise mixture, ensuring the recycled metal meets the rigorous standards for aerospace use.
The purified alloy is now transferred through heated channels toward the precision casting station.
Internal gases are purged using argon bubbles, ensuring the final metal is free from structural porosities. The molten metal enters a degassing box, where a graphite rotor spins at high speed, injecting argon gas bubbles.
Final filtration through ceramic foam removes even the smallest inclusions, achieving medical-grade purity.
The metal flows through a porous ceramic foam filter, which looks like a white sponge.
The liquid alloy is now poured into precision molds, beginning its transformation into solid aerospace ingots.
Solidification is carefully managed, with laser sensors maintaining micron-perfect accuracy for every ingot produced.
As the molds move, the edges of the metal begin to solidify. A laser sensor monitors the surface height.
As the molds move, the metal begins to solidify. A laser sensor monitors the height to ensure every ingot is exactly the same weight.
Advanced water quenching quickly brings the temperature down, locking in the alloy's crystalline structure.
Robotic handling systems automate the removal of finished ingots, ensuring a continuous and safe production flow.
Every ingot is laser marked with a unique ID, providing total traceability from the recycled aircraft to the final product.
These stacks represent millions of dollars in reclaimed material, ready to be forged into new aerospace components.
For titanium, the process is even more rigorous, occurring within an oxygen-free vacuum to preserve the metal's unique properties.
In the vacuum furnace, titanium is purified by fire, shielded from oxygen to maintain its legendary strength. Inside the vacuum arc remelting furnace, an intense electrical arc melts the titanium electrode into a high-purity molten pool.
10,000 tons of pressure forge the recycled titanium, refining its grain structure for maximum durability. Composite materials, once impossible to recycle, are now shredded to reclaim valuable carbon fibers.
Using pyrolysis, we vaporize the bonding resins, freeing the carbon fibers for a second life in manufacturing. Inside a nitrogen-purged thermal chamber, the resin holding the carbon fibers together is vaporized at high temperature.
Ultrasonic scanning peers inside the solid metal, ensuring every recycled ingot is structurally perfect.
Once the aluminum is recycled, it undergoes ultrasonic testing.
Miles of internal wiring are reduced to pure copper and silver, reclaiming the nervous system of the aircraft. High-value avionics yield a hidden treasure of gold and palladium, recovered through advanced chemical precipitation.
The filter paper is carefully lifted, revealing the culmination of the process.
The final step is to stamp the pure, recovered gold with the company logo before it is reintroduced into the supply chain. In the final lab, every batch must pass extreme stress tests to ensure the recycled metal is as strong as new. The tensile test pushes the recycled aluminum to its limit.
All the ingots are cleared.
Excellent. I'll log it in the system.
Our automated warehouse manages thousands of tons of inventory with surgical efficiency and zero human error.
We close the loop by converting non-recyclable waste into clean energy, powering our mission for a zero-waste future.
Non-recyclable materials are fed into a high-tech gasification chamber that converts waste into clean energy to power the factory.
From retired aircraft to certified raw materials, this facility represents the pinnacle of large-scale circular manufacturing. In this industrial graveyard, millions of parts are recycled in a perfectly synchronized operation.
This state-of-the-art facility processes thousands of tons of retired aircraft aluminum every year.
Millions of parts, now reborn as ultra-pure alloys, ready to return to the skies in the next generation of flight. How millions of aircraft parts are recycled inside a massive factory.
We are redefining the future of aviation, ensuring
The final supply chain is activated, delivering high-purity alloys to manufacturers across the globe. These titanium ingots, recycled from aircraft parts, are being loaded onto a specialized transport ship for global supply.
How millions of aircraft parts are recycled inside massive factory.
The recycled material is reborn, cast into high-performance components for the next generation of aerospace engineering.
The recycled aluminum is melted down one last time and injected into a precision mold to create a brand new aircraft wing rib. Every gram of material is accounted for, completing the most efficient industrial loop in modern history.
The cycle is complete.
The future of aviation is infinite.